overview of a new project we're working on, which is called a railgun. It's a projectile-based weapon that uses an electromagnetic charge to propel a round however fast we want it to. Some of the interesting components of this, because it uses electromagnetic energy, it's completely silent, and we can also adjust how fast it goes. I'll be going over a few parts of this really quick. First off, we have this plastic barrel, and we use plastic because it's non-magnetic, so it doesn't interfere with any of the firing. On the bottom here, we have our capacitor bank, which charges the coils. Right now we have 15 capacitors, but we will be adding more as we add more coils. That is charged essentially by this inverter circuit, which is in turn powered by 10 D batteries, which are right here. This is the type of round we'll be shooting. It actually consists of a practice arrowhead that we were able to buy from Gander Mountain. The reason we got it is because it's easy to assemble and cheap, but originally the way it is supposed to be assembled is like this. The reason we changed it around is so the back has more surface area than the front, but the front is still heavier. This means that the center of gravity is in front of the center of pressure and will remain stable in flight without having to rifle the barrel. This is the magazine we're using to hold rounds. It's assembled from clear plexiglass, and these little catches here are actually door catches, which will allow us to clip it in to the gun. This is actually what we use to push the rounds in. This assembly right here. It's actually made from a drumstick, and we cut off most of it and allowed it so it can swing like this and push rounds into the barrel. Over here we have a servo, which is actually what pushes the rounds into the barrel. We assemble the pusher on here, the plunger, and the servo engages and pushes the plunger into the magazine, which therein pushes a round into the barrel, and that allows us to fire. Over here we have our microcontroller. This will control a number of systems in the gun, such as the LCD screen right here, which will supply things such as voltage and velocity once we get those hooked up. It also controls the servo, so that can swing back and forth. And over here we have the trigger for the gun. We actually got this from a paintball gun, but we're able to reverse engineer it a little bit so it was able to supply the trigger we need to activate the coil. This is a little bit of a closer look at our inverter circuit. Right here, we have an oscillator, a phase inverter, and those drive two MOSFETs right here, which in turn drive these two transformers. And those transformers give us the 1,000 volts we need for our capacitors back on the gun. Right now, it's a work in progress, and our parts may be a little disparate, but we're planning to finish it up by the end of the school year.